All right, so here we're going to solve a system of 3 equations and 3 unknowns. I'm not going to do this using matrices. We'll just solve it as if it's the first time students are exposed to this. So the idea here to solve a system of 3 equations, these x's just represent entries. This is our equal sign. This is basically the form of a system of 3 equations and 3 unknowns. This is the basic idea. What we want to do is we want to get this entry and this entry to be 0, because once those are 0, we have this. And we do that by adding multiples of this row to these. Then the next step is we want this entry to be 0, and to get that to be 0, we multiply the second row by some number and add it to here to get this entry to be 0. Once we have this, we use back substitution. Plug this value in here, solve for this. Once we know those two variables, plug them in here and solve for that. So that's the basic idea. To get there, what we want, the easiest thing is we want this upper left-hand quarter to have a coefficient of just a 1x. I could divide that by 2, but we're going to get fractions. We don't want that. It's going to make the arithmetic too hard. So let me just interchange these 2 rows. So what I like to do for every operation, I like to notate it and tell students to do that, because if they do get to the end and they find they made a mistake, when they go back and check their work, if they know what operation they did each time, it's easy to check that operation. So what I'm doing is I'm interchanging row 1 with row 2. So I'm just swapping them. So row 1 becomes row 2. This one moves down here. And the last row remains unchanged. Okay, so now we can start, like I was saying before, we want this entry to be 0, and we want this entry to be 0. So to get this entry to be 0, we need this to be a -2. So we multiply row 1 by a -2 and add that to row 2. Now I could also get rid of this at the same time, but I'm going to do it in 2 separate steps. So the only row that's going to change is row 2. So let me write the other rows down. Now let's do this operation. -2 times x is -2x, and 2x is 0. -2y and -y is -3y. -2 and -3 is -5z. -2 times 2 is -4, plus 3 is -1. All right, now like we said, our next step is to get that entry to be 0. To accomplish that, we're going to multiply row 1 by -3, plus 3 gives us our 0. So we're going to multiply row 1 by -3 and add that to row 3. Row 3 is the only row that's going to change. So let's write down our first 2 rows. X plus y plus z equals 2. Minus 3y minus 5z equals -1. And now let's do this operation. -3 and 3 is 0. -3 and 2 is -1. Why? -3 and -1 is -4z. -3 times 2 is -6, plus 8 is +2. Now, like I explained at the beginning, our next step is to get this entry to be 0. But just like over here, it's convenient if this is just a y or a -y to just multiply it to make this 0. So here, let's interchange these 2 rows, the second and third row. So row 2 and row 3 are interchanged. x1, the first row remains unchanged. This one goes up here. And this one comes down here. Okay. Now, what might be nice to make the math a little easier, you don't have to do this, but if I multiply the third row by -1, it just makes everything positive. And that just kind of helps with our arithmetic. I'm going to do that. So now, and I probably should have showed that as a step if I was teaching students, but now what we want is this entry here to be 0. Well, to get that to be 0, we got to multiply row 2 by 3 and add that to row 3. So row 3 is the only row changing. So let me write down the first 2 rows. Now let's do this operation. 3 times -1 is -3, and 3 is 0. 3 times -4, -12 plus 5 is -7. 3 times 2 is 6, plus 1 is 7. Now we can use back substitution. -7z equals 7, we can solve that. When we divide both sides by -7, we find z is -1. Plug that into this equation. Minus y minus 4z, z is -1, equals 2. And then just do the arithmetic. This is a +4. Subtract, we get a -2. Multiply by a negative, and we find y is +2. Now we take those two and plug them into the first equation. So we have x plus y, but y is 2. And then we have plus z, z is -1, and that's equal to 2. And then we just solve this. This is a 1, subtract 1, and we find x is 1. Now we could check our work. To check our work, we need to plug 1 in for x, 2 for y, z, -1 for z, but we need to do it, plug it into all 3 of these and make sure we end up with 3 equals 3, 2 equals 2, 8 equals 8, that it works for all 3 equations.